this video, we will continue talking about functions in C++. So let's talk about returning a value from a function. So we used before the function bow. This function, like it's a built-in function, but it takes two parameters and it returns a value. So we assign the value it returns to some variable x. So this means that this function takes some input and produce some output or return value. So we will see how to make such a function. So if the value returning function, this is another type of function other than the void function. So in these functions, the return will return some value. So for example, here we return result. So this is a function called sum. It takes two parameters, num1 and num2. It has a result and it's sum num1 plus num2, and then it returns a result. So if you see that when we define the function, we have to write its int. This means that it returns integer value, which is result. But result is double here, so it should be double. So for example, the value that has returned should be the same that the value. So this is a mistake in the slide. This should be int, for example, or this should be double, because the value that we return should be from the type integer. Okay, so this is another example. We can make the function sum. It returns integer. It takes two integer, but we can make it as return num1 plus num2. So we can make expression in the return, not only a variable. Or we can make a value, a variable, or expression, something like this. So this is example. In this example, we will make a function. This is the function prototype. It's sum. It takes two integer and it returns integer. Let's look to this function. It takes two integer and return num1 plus num2. Let's go back to the code. We call this function here. So we define a variable total of type integer, total equal to sum value 1 value 2. So this function will return a value and we will store this value in the variable total. So total will have 60 because 20 plus 40 is 60, and when we print it will print 60. Okay, the sum of 20 and 40 is 60. So this is what's happening. We pass argument to this function 20 and 40, and this function do something and return some value. The value that it returns is 60, so it will be stored in the total. So for example, square, we give it 10. There is a function called square. We give it 10, and this function multiplied 10 by 10 and return 100. So the value that it returns is 100. It's multiplied by and then stored in the area. So the prototype and the function must indicate the data type of the return type. It should, if we write a prototype for these functions, we should not write void. We should write whether it return integer or double or something. When we call this function, you should store the value either in a variable, or you print what the function return, or you use it in expression, something like this. So here we use the return value of the function square in expression by multiplied by return value of square. So we can do all these, one of these three things with the returning value of the function. So the function also can return a Boolean. In this case, the function can return true or false. When we write the prototype, we will write bool, which means the function return Boolean, and the function must contain return true or false. Okay, so let's take example. For example, this function bool is even. It takes some number, and we define Boolean called status. If the number is even, status is true, otherwise it's false, and then we return status. So this function tells us if this number is even or not. So we can use it here. If is even val, Val is some variable that we get from the user. So is even, it returns true or false. Imagine it's even, so it returns true. So in this case, we will print val is even. Otherwise, we'll print val is odd. So we can use the function that return Boolean in the condition of if or while. So let's talk now about local and global variables. We have local and global variables. Local variables are variables that are defined inside the function, and they are only visible inside the function. They are not visible outside the function. So for example, here we have the main function. We have integer variable called num. We have another function called another function. It has a variable num of type integer. There is no contradiction here, no conflict between the two variables, because this variable is only visible here. This variable is only visible here. This is local inside the main. This is local inside the another function. So as we said, there is no conflict. When we execute, there will be no problem between these. So the value of this variable is 1. The value of this variable is 20, and there is no conflict. So the local variable lifetime, a function local variable exists only when the function is executing. So imagine we have a local variable for one function. If this function is executing, the variable is alive. After the function is finished from execution, the variable will not exist anymore. Okay, so we call this the lifetime of the local variable. When the function begins, the local variable and its parameter are created in the memory, and when the function ends, the local variable and parameter are destroyed from the memory because we don't need them anymore. So that's why sometimes we need global variable and global constant. Global variable is any variable defined outside the function of the program, and the scope of the global variable is all the program. Okay, from the beginning of the definition till the end of the program. So it can be accessed by all functions that are under the global variable definition. We should avoid actually using global variable because sometimes it makes mistakes and it's difficult to debug, because the same variable is changed in different function. So this is normally not good. Usually we use global constant. It's good to use. For example, in this example, we use constant double pay rate, constant double base hours, constant double out multiplier, so overtime multiplier. So these constants are visible by all function, and it's fine because they are constant, so no function can change their value. Okay, but we can use them here, we can use them here, we can use them here in different functions of the code. Okay, how about initialization local and global variable? So local variables are not automatically initialized. We must give initial value to the local variable, but the global variable, which are not constant, are automatically initialized to 0 if they are like integer or doubles or something like this, or to null character when the variable is defined. So let's talk now about static local variable. Sometimes local variable only exists while the function is executing. As we mentioned, when the function terminates, the content of the local variable are lost. Static local variable retain their content between function call. So sometimes when you call the function many times, you want to save the value of this local variable. Let's take example. We have a main function. We are calling some other function called show local 2 times. So when we call show local, it defined local number to 5, and then it's print this number 5. After that, it gives 99 to this number. So when we call it, it gives it to 5 and then print it. So 5 will be printed. Next time you call it, it print it as a 5, even though in the last call it was changed to 99. So this will not be changed because this local variable was destroyed after the first call. So after we call the function again, it defined a new variable with 5, and then it was printed, and after that it was changed to 99. So if we don't want something like this, if we want to keep the value of the variable between the function calls, we need to use something called static local variable. For example, this function void show static, it has a static int stat num. Okay, this is local variable. Static local variable by default are giving value 0, okay, as initialization. After we print it, it will be printed as a 0, and then we increment this. Okay, so after we finish this function, this variable will not be destroyed because it's static. So we will wait, maybe we call this function again. So here we call this function 5 times, it was in a loop. So every time we call the function, we print and then increment. After we call the function again, we don't print 0 again, no, we print 1. We continue from the previous value of this static local variable. So as you see, if you call another 5 times, it will be printed like this. If the initialization was 5, so it will print 5, but after you call it next time, it will be 6 because we increment. After you call it next time, it will be 7, 8, 9, and so on. So let's talk about default arguments. Default arguments is sometime when we define a function, we want to give default values for some parameters. Okay, for example, void even or odd. This is prototype, so it's taking integer. If we write integer equal to 0, this means the default value for this parameter is 0. Okay, sometimes we can have 3 parameters. We want to give default value for the last 2 parameters to be 0. So this is example. We have a function called display stars. Let's see this function. It takes columns and rows. It's print how many stars, like how many columns of stars and how many rows of stars you want. Okay, so first we print for rows, and for every row we print how many columns stars in this. So it's nested loops. Okay, so if we give this like if we give this 1 and 7, it will print something like this. If we give 1 and 5, it will be print something like this. If we give it 3 and how many stars here, 7, 3 and 7, it will be print something like this. So when we define this function in the prototype, we give initial value that the numbers of columns is 10. Sorry, the number of columns is 10, yes, and the number of rows is 1 by default. So if you call display stars without giving values, it's okay because there are some default values. It's like you call this function with the values 10 and 1. So it's like you want to print one line with 10 stars because you didn't mention the value, so it will take the default values. If you give it only one value, so it's like it will print 5 stars in one line. Okay, so this is, we change only the 5. If you give it 2 values, so it will ignore the default values. It will give 7 stars in 3 lines. So this is what's happening here. So this is the idea of the default argument. But please, if you want to make default argument, first you need to define the argument that does not have default value, and then the argument that has default value. So it's okay to define it like this, but it's not okay to define it like this, because you should bring this variable here before the default values, also the last values. Also, if you want to call this function, okay, you should omit, if you omit one argument, you should omit all the argument after it. Okay, so now let's talk about using reference variable as parameters. Sometimes, if you remember in this chapter, we talk about call by value. Call by value, when you call a function, the function take copy of the argument and cannot change the variable. But here you have the option to make it a reference. You make pass by reference and not pass by value. How to do that? In the prototype, you write this sign after defining the parameters, okay? And so void double num int, and we have this reference sign. So now when you call this function in a variable, you are giving this variable to the function, and the function has the right to change the value. So the value was first 4, and then you call the function, and you will see the function maybe change this value. The function has right to change this value to another value. So after this, we want to print the value again, and you will see that the value was first 4 first, and when we pass it to this function, the function multiplied by 2. So after that, the variable value in the main function was changed to 8. So when we write this, this means the function has the right to change the variable which was in the main. So the function was able to change this value from 4 to 8. So this is called pass by reference. So if you want to make pass by reference, each reference parameter must contain this sign, and you can make space or without space as you like. You have to use it both in prototype in the header if you want to use a reference, and the argument passed to the reference parameter must be a variable, cannot be expression. So you only make reference for a variable, no values, no expression. Use when appropriate. So we should not use it much, this pass by reference. In some situation when you want the function to return values, more than one value, you can use this trick. Otherwise, we should not use pass by reference. So let's talk about overloading function. Overloading function is just different function with the same name but with the different parameter list. So for example, here we have 4 functions, all of them called getDimension. The first one take integer, the second one takes 2 integer, third one take integer and double, fourth one take double and double. So the compiler can differentiate. If we call this function, which one we mean depends on the input. If we give one integer input, then we mean the first one. If we give 2 integer, then we mean second one. If we give integer and double, then we mean the third one. If we give double and double, we mean the last one. So this is the example. We define 2 prototypes of 2 functions. They have the same name, but they have different parameters. The first one is integer, second one is double. Okay. So you see here we have 2 functions. The first one take integer, second one take double. So when you call it, depends on the argument. If the argument is integer, it will call the first one. If the argument is double, it will call the second one. So this is called function overloading. It's like we have 2 versions of the function. One version that takes integer, another version that takes double. Okay. So the last sections I think are less important. There is some function called exit that cause the program to exit. If you want, you need to include a C standard library if you want to use this exit. Normally we don't use it much, but if you use it, you can give it also 0 or some other constant if you want to say that you want to exit with a normal without problems, or you want to say we exit with error. But as I mentioned, it's less important. Same like stubs and drivers. Sometimes you have a code, a lot of functions, and there are some problems with some function, but you don't know which function you have problem. So sometimes you use stub. Stub is a dummy function used in place of actual function. So you replace some function, you comment this function by another function, and the other function just take the arguments and print them and see the return value and check if the arguments are correct or not. There is another thing is called driver. Driver is just a function that call another function and test if the other function is working good or not. Again, this is some concepts that are in the debugging, and that's the end of this chapter, and see you in the next video.